So hi and hello there, welcome to the new video. And in this particular video we are going to see the drawback, the concept of the drawback that we had discussed in the previous video. If you could remember, we had designed a 9-volt battery indicator circuit, and the problem or the drawback that we were facing was that even though we had open circuited this particular circuit, that means even though we are not connecting any battery to this particular circuit or across this particular circuit, still the red LED, it was in on condition. If you could see, let me run it so you can clearly see the red LED, it is in on condition even though we had not connected the battery across this particular circuit. Okay, so now we are going to understand this particular concept. So let me come on the blackboard. All right, so you can clearly see I'm not applying any voltage across this particular input terminal of the NOT gate. So pin number 1, it is the input, pin number 2 is it is the output. So you just as of now you just focus on the first two pins. Pin number 1 is your input, pin number 2 is your output. Okay, so if I'm open circuiting pin number 1, that means if I'm not providing any voltage, or if I'm not connecting this particular pin number 1 either to VCC nor to neither to VCC nor to ground as well. So in that particular scenario, what would be the output? Okay, so first of all, what we will do, we will simulate this particular circuit. That means I'm not connecting pin number 1 to VCC as well, and I'm not connecting it to ground as well. So we will simulate this particular circuit on the Proteus software. We will check the result, and then we will simulate it on the in the Thinkercad software, and then we will check the result. Okay, so let me go to the Proteus software. Let me open this window. Yeah, as of now you just don't focus on this particular circuit. No need to focus on this particular circuit. Just focus on this part. See, just focus on this particular circuit. All right, so let me run this particular simulation. So you can clearly see I'm not applying any voltage to the input side of this particular NOT gate. So this is the practical NOT gate 7404. I hope you know the difference between practical and ideal. So practical means what? To the pin number 14 we should apply VCC, and pin number 7 we are applying ground. Ideal means what? We are not bound to apply any voltage. We are not bound to give any ground or voltage across that particular IC, right? This is what the ideal case scenario is, right? But over here, this particular IC, it will inherently assume that it is getting plus 3.5 to 5 volts. Okay, and then then it is grounded internally. Okay, that means this particular scenario, that means it will inherently assume that pin number 14 it is getting plus 3.5 to 5 volts. Okay, and the pin number 7 it is grounded. It has been internally assumed by this particular IC. Okay, so you don't worry about that particular part. Let me run this particular simulation. Okay, so you can clearly see the LED, it is in off condition. Okay, the LED, it is in off condition. Okay, so let me stop this particular circuit. Okay, now we will go to the Thinkercad software, and we are going to simulate the same circuit over there. All right, so let me stop the simulation first. All right, so over here, this is the pin number 1, that is the input terminal, and this is the output terminal. That means we are just focusing on this particular part. Okay, pin number 1 is your input, pin number 2 is your output. So you can clearly see I had not applied any voltage to the pin number 1. Okay, I'll just connect this particular pin over here. Just a second. Yeah, okay, but you can clearly see I had not connected this particular pin either to VCC, neither to VCC nor to ground, right? I had not connected this particular pin to VCC and nor to ground as well. That means what? I'm not applying any voltage to this pin number 1, or rather I'm not giving any input voltage to this particular NOT gate. Okay, I hope you are getting this particular point. That means what? My NOT gate is facing the open circuit. Okay, my NOT gate is open circuited. Now what we'll do, we'll run this particular circuit. Okay, you can clearly see the LED, it is in on condition. So even though I am not providing any voltage to the input terminal of the NOT gate, still this particular LED, it is in on condition, whereas the scenario was different when we simulated the circuit on the Proteus software. Let me run it over here. So you can clearly see this particular LED, it is in off condition. Okay, so let me stop this particular simulation, whereas in case of Thinkercad, this scenario, it is exactly opposite. Okay, so let me stop this simulation. So now we'll try to understand that what is the reason behind it. Let me go over here. Yeah, so over here, what is the truth table of NOT gate? So if this is your NOT gate, if we are providing A as the input, if my A is 0, so at the output I will get 1. If my A is 1, so at the output I will get 0, right? This is the basic understanding, or this is the basic working of NOT gate. Okay, but if I'm not providing any voltage to the NOT gate, that means if I'm open circuiting the NOT gate, that means if I'm not providing any input voltage to the NOT gate, So the NOT gate will provide either the NOT gate will provide output as 1, or it will provide the output as 0. It totally depends on the designer, how the designer has designed this particular NOT gate. Okay, so don't get confused in this particular part. The NOT gate will strictly provide at least one output, so the it can be 1 or 0. Okay, it cannot provide any other output other than 1 or 0. Of course it won't be able to provide any other output. Why? Because when we are dealing with digital electronics, either the output would be 0 or it would be 1. Okay, you cannot get any other output apart from that. Okay, so that's why the designer will design this particular NOT gate or this particular circuit in such a way that even though we are not providing an input voltage to the NOT gate, so it will provide either 1 or it will provide either 0. Okay, it cannot provide both of them at the same time. Okay, so it will provide either of them. So basically in the Proteus software, what is happening, so when we are keeping the input terminal as an open circuit, or rather when we are not applying any voltage to the input side, so we are getting the output as 0, and this is happening in the Proteus software. So let me write over here, this is happening in the Proteus software. Proteus software. Whereas things work in the opposite way when we are simulating this same circuit in the Tinkercad software. So basically when we are not providing any input voltage to this particular NOT gate, we are getting the output as 1, and this happens in the Tinkercad software. Tinkercad software. Okay, and same happens in the real life scenario as well. Whenever you take IC of different companies or from different manufacturer, okay, or from different designer, okay, so you can notice the same thing over there as well. Okay, so now what we are going to do, we are going to simulate this particular remaining circuit. That means what, I will connect this pin number 2 to 3, okay, and then I'm going to take the output from pin number 4. So basically what I'm going to do, let me go to the Proteus software. Proteus software was when we kept the input terminal as an open circuit. So at the output side we are getting logic 0. Okay, so this is what we saw in the Proteus software. Okay, so let's come to this particular to the Proteus software, and what I'm doing over here is that I'm keeping the input terminal as an open circuit. So this is an open circuit. That means I'm not providing any voltage, okay, or rather I'm not connecting it to VCC, neither to ground as well. So basically this is an open circuit. Okay, so in the Proteus software we saw at the output side we should get logic 0. So this is over here we will get logic 0. Okay, and since this particular 0, it is been given to the input of the second NOT gate. So at the output of this particular NOT gate we will get logic 1. Logic 1 means what, this particular LED, it would be in on condition, or rather it will emit light. So it will emit light. Okay, so now let me run this particular circuit, and let me run this particular circuit, and we will check if this particular LED it is in on condition or not. See, this particular LED will glow, whereas this particular LED it would be in switch off condition. So you can clearly see this particular LED, it is in on condition. Okay, you can clearly see it is in on condition, and the reason is pretty simpler. This is because if I am providing, or if I'm open circuiting the input terminal, okay, if I'm not providing any voltage to the input terminal, so basically I'm open circuiting it. So this will act as an open circuit, right, since I'm not providing any significant input to this particular input terminal of NOT gate. So over here it will behave as if it is getting logic 0, and since it is getting logic 0, that's why this particular LED it is in off condition, right? So this particular logic 0, it will be getting reflected over here, and to the output side you will get logic 1. Logic 1 means what, the LED would be in on condition, and you can clearly see it is in on condition, or rather it will emit light. And this same concept was being used when we had deal with that particular project. So let me erase all of these things. Let me erase all of these things. Okay, I hope you understood this particular thing, okay, or this particular concept. Now we will go to, just a second, we will go to that particular project. So over here you can clearly see this same concept is being reflected over here as well. There are two NOT gates. So since over here it is getting open circuited, okay, you can clearly see, since I'm not providing any voltage across this particular circuit, so you can clearly see this will act as an open circuit. Okay, so over here you are getting open circuit. Let me write over here as well. So over here you are getting open circuit, open circuit, open circuit. So in the Proteus software, this particular IC, it is designed in such a way that at the output side it will provide logic 0. Okay, logic 0, and since it is getting logic 0, so therefore at the output of the second NOT gate you will get logic 1, logic 1, and therefore this particular LED, it would be in on condition. And if you could see very clearly, let me run this particular circuit. So that's why this particular LED, it is in on condition. So this was the reason, okay, why this particular LED it is in on condition. And if you could remember, I showed you the video where I had implemented the same circuit on my breadboard as well. So even I was getting the same result. So at first I thought that this was because I connected orange LED over here, but no, that wasn't the reason. The reason was, if you are keeping the input terminal of NOT gate as an open circuit, so it will provide either of the output, either it will provide 0 or it will provide 1. Now we are going to simulate the same circuit on the Tinkercad software, but before that let me just erase this. Okay, let me just erase this. Okay, alright, so now that we had simulated this particular circuit on the Proteus software, so let me go on the blackboard. So now we will simulate the same circuit on the Tinkercad software. Okay, that means we are open circuiting the input terminal of NOT gate, and then we will check the output. Okay, so in the Tinkercad software, what I had done, so basically I had implemented the same circuit. Just a second. So I had open circuited pin number 1, that means I'm not providing any voltage across pin number 1. Okay, and then pin number 2, it is short circuited with pin number 3. Okay, and then whatever the output that is being generated by this particular NOT gate, that would be displayed by this particular LED. Okay, so what we saw in the Tinkercad software when we just simulated with one NOT gate was, see, when we are open circuiting the input terminal, that means pin number 1, so at the output side we should get logic 1, right? So at pin number 3 we are getting logic 1, so at the pin number 4 we should get logic 0. That means this particular LED, it should be in off condition. So let's check this particular scenario if it is getting executed properly. Okay, so you can clearly see, just a second, yeah, this is pin number 1, this is pin number 2, right? This is pin number 3, this is pin number 4. Great. So you can clearly see I'm not giving any voltage, or rather I'm not providing VCC, neither ground as well, to the pin number 1. So this is pin number 1. Okay, so at the pin number 2 we should get logic 1, and if it is getting logic 1, that would be reflected at the input terminal of the second NOT gate, that means pin number 3, right? And then at the output side, this particular LED, it should be in off condition. So let me start the simulation, and I had kept the input voltage at around 2 volts. Okay, I mean the VCC at around 2 volts. Alright, so you can clearly see this particular LED, it is glowing, but it is quite dimmer. So let me connect this particular LED to pin number 2. Okay, if I connect this particular LED over here, that means to pin number 2. Okay, you can clearly see this is output 1, that means pin number 2. So this particular LED, it would be in switch on condition, or it will glow brighter. So let me just stop the simulation, and let me just connect this particular LED over here to pin number 2, and now let me just run this particular simulation. So you can clearly see now this particular LED is glowing brighter. That means what? It is getting logic 1 over here. Now let me stop the simulation, and let me just connect this particular LED over here at pin number 4. So you can clearly see this particular LED, it is still glowing, but it is quite dimmer, which indicates that it is getting logic 0 over here at pin number 4. Okay, so long story short, what I wanted to conclude in this particular session was this. That means if you are not providing any input voltage to the NOT gate, so you will either get 1 or you will get 0. It totally depends on the designer, how that particular designer has designed this particular NOT gate, or rather IC7404. Okay, so you know, that's the reason, like why that particular LED was in on condition, even though we were keeping this particular part open. Okay, so now I hope that you understood this particular concept in depth. But still, if you have any doubt, if you are still facing any difficulty, you make sure to ask me down in the comment section. I will surely help you out there. So thank you.